And we are live. Who's going to be the first to join? We are live. This is now our third session. Okay. So in today's session, we're going to be doing the AQA. Sorry. We're going to be doing the AQA June 2022. Sorry, specimen paper. For the AQA A-level maths paper 1. Okay. This is still going to be relevant. Okay. If you're doing other examples. Hello, Iqbal Hassan, welcome, 183, welcome my friend, hope you're well. Let me know guys, can you hear me? Is the audio clear today? I'm not on mute, am I? Just double checking. Hello, hope you're well. How are we doing guys? Okay, we are obviously 1 minute or 2 minutes early. Okay. Thank you so much. Yeah, thank you, Iqbal Hassan, for the follow. Thanks so much for the follow. Guys, if you're new around there, make sure you give us a follow. Subscribe to me on YouTube. Yeah, subscribe to me on YouTube as well if you can. Okay, all live recordings after each live gets uploaded, usually straight away or a day later, okay, to my channel. Okay, but today we're going to be doing the AQA A-level maths paper 1 specimen material. Okay, hello Angel, hello Henry, welcome, nice to be in the chat. Hello Martin, welcome, hope you're well. Okay, we're going to do like a select few questions. Hello Jessica, welcome, hello Linda. Hello, nice to be in the call guys. Okay, thank you for liking it, thank you for liking. Thank you so much user for liking. Hello Jason, hello Aman, welcome. Hello user 603, welcome my friend. Hello, hope you're well. Hello Sam, welcome guys. Let me know, can you hear me? Hello Lena, welcome. Guys, let me know, can you hear me? Is everything clear? Hello NR, hello Norwich Dave. Welcome. Okay, just giving a few minutes for people to join. Hello Aurora. Hello Denny, welcome. Hello user 772. Welcome my friend, welcome. Hope you're well. Guys, if you're new around here, please give us a follow. Hello Mike, welcome. Hello Wisdom. Okay. And subscribe to me on YouTube. Okay, hello, Salam, welcome. Hope you're well. Hello, E. Thank you. Yes, quite a few of you on tonight, guys. This is awesome, okay? Hello, Badman. Hello, user.clips.16. Welcome. Hope you're well. Okay, we'll make a start in just the next minute or so. Okay, just giving chance for people to join. Hello, Love Hearts. Welcome. So he's got a question actually, a very good question. I've never tried A-level maths and have no knowledge of it. Is it easy to teach myself the course? That is quite a good question. Yes, good question. I mean, to teach A-level maths here, like self-teach, I'd say is quite tricky. I mean, it's doable, but I think it's quite tricky. Okay, um, there are some really good YouTubers out there. Okay, so hello Olivia, welcome. So TL Maths, I think is one of the best out there. Exam Solutions, and also Mr. Bison. There's a guy called Mr. I think is Asbury or Asbury. Hello, Free Palestine. Hello, Valdig. Um, so yeah, I would check out. I think TL Maths here. I think is like one of the best here for like self-study A levels. Hello, welcome. Um, but that would be my advice. For that. Okay. Um, I mean, probably it might be worth doing like an online course where you have like a tutor where you can get some feedback, okay, um, on like a one-to-one basis, okay. Um, but yeah, I think it is actually is doable for sure, but I think it's actually quite tricky, okay. I think A levels, yeah, like maths or science, yeah, I think are quite tricky to like self-learn and self-study, okay, but nothing is impossible, okay. Guys, let me know. Shall we make a start or shall we give it another minute or so? Okay, I want to try and give a chance here for people to join. Hello, Ataya. Welcome back. Nice to be in the call. Thank you so much here. Thank you, E, for the follow. Okay. Um, but I've got loads and loads of content for A-level maths on my YouTube channel for the pure math section. Okay, on my playlist from 2 and 3 years ago. Okay, so I would check out my videos on that. Okay, alternatively, check out TR Maths or just enroll onto like the cheapest like online self-study A-level maths course. okay, and get yourself like assigned to like a one-to-one tutor on a temporary basis. Okay, Valdek's got a question here. Okay, I'd rather not actually answer that, Valdek, here, but I can teach A levels, yes. Okay, so I'm actually beyond that shit. So I've passed university, yeah, and also A levels this year. Okay, but sorry, yeah, not to answer your question. Sorry, yeah, I'm just a bit not personal, but I'd rather not like disclose that. Sorry, I actually do apologize. Hello and welcome. Um, but yeah, okay. But I am actually a fully qualified teacher. Yeah, okay. At the moment, yeah, I'm doing some like one-to-one tutoring, for a company, and also I do some work in schools. Yeah, like some voluntary and some paid work. Okay. At the minute, hello user, welcome. Okay, but no worries, yeah, no worries. Yeah, okay. But if you are actually wondering, yeah, I am like 29 years, so I'm 29 years old. Um, yeah, like a postgraduate maths, yeah, and the teaching. Okay, but there you go. Okay, thank you so much. Yeah, thank you, N, for liking. Right, guys, let's make a start. Okay, so let's make a start. Okay, again, guys, yeah, sorry about any like technical actually issues here. I can't like edit the paper here because it says the file has limited permission. Okay, so I'm gonna have to copy and paste the questions onto a PowerPoint. Okay, we're gonna be live here for about an hour tonight. Yeah, not too long tonight. Okay, well, question one's on the screen. Okay, and then question two is also on the screen. Okay, I'll give you 1 or 2 minutes to try the questions, and then we'll do the answers in a second. Okay. Okay, he's got another awesome question. Okay, do you think if I taught myself that I could increase my chance of a scholarship if I mastered it? I think you can, yes, E. I think you can, yeah. Thank you so much, yeah. Thank you, Valdic, for liking. Yes, I think you can, E, yes. Um, I mean, like I said, yeah, obviously, like self-studying, yeah, I think A levels is more of like a trickier, okay, I'd say yeah, it's a lot more demanding. I mean, it's doable, yeah, don't get me wrong, yeah, it's doable. Um, but yeah, but I think as you get obviously a little bit older, yeah, like it becomes harder and harder to like learn like new things. Um, yeah, okay, because like I could give you like the world's best textbook here, okay, but if it isn't like tailored to like you and your needs, then like you know what I mean, like there's no point in doing it if that makes sense. Yeah, I hope that actually helps you answer the question, guys. If you're new around here, make sure you give us a follow. Okay, is this actually A level? Well, look at the front, Salmon. Sorry, not Salmon. What am I saying? Look at the front here. What does that say there? Okay, I'm gonna let you decide. Anyway, sorry. Question number one. Okay, type in ready when you're ready, guys, and we can talk about it. Okay, question one says find the gradient of the line with equation 2x plus 5y equals 7. Circle your answer. So rearrange it so it's in the form y equals mx plus c. Okay, why are you acting like I could see the front cover? What do you mean? Sorry, what do you mean? What do you mean? Okay, so rearrange it to make y the subject. So subtract 2x and then divide by 5. You get y equals 7 minus 2x all over 5. The gradient is the coefficient of x. So it's minus 2/5. So our answer will be minus 2/5. Hello, Peter. Welcome. Okay, thank you. Thank you for joining. Okay, thank you for joining. Okay, so just quickly doing it on the screen. Okay. Hello, Hassan. Welcome. Thank you. Yeah, thank you guys actually for joining. Okay, thank you for joining. Okay, so just briefly, okay, I subtract 2x on both sides, okay, and then I divide by 5 because I want to get it in the form y equals mx plus c. Hello, Abby. Welcome, Abby. Thank you for joining. Okay, thank you for joining. Okay, and then divide by 5, we get y equals 7 minus 2x all over 5. Okay, why is it doing it now? Ignore that, guys. Yeah, ignore that. Okay, so it should be, sorry, that is not a 1 there. Okay, so it's 2/5. So our answer is 2/5. Okay, if you got that, well done. If you didn't get that, hopefully it makes sense. Okay, but that is, yeah. rearranging formulas. Question number 2. A curve has the equation y equals 2 over the square root of x. Find dy by dx. So step 1, write it in index form. So you have y equals 2x to the power of minus a half. So y equals 2x to the power of minus a half. Why is it doing this, guys? Why is it doing it? It's so annoying. Okay, dy by dx. So you differentiate that. Okay, so dy by dx, the power comes down as a multiplier and the power reduces by 1. Oh, this is annoying. This is okay. But I hope it's still legible. Okay, why is it doing this, guys? Why is it doing this? This is annoying. Hello, AMK. Welcome, welcome. Hello, hello. Guys, if you're new around here, make sure you give us a follow. Okay, and check out the content on my YouTube. Okay, for just seeing A-level maths. So differentiating this, 2 times a half becomes minus 1. So it's minus 1x, okay, to the minus 3 halves, okay. And then I'm going to flip it. So I'm going to have minus 1 over x to the 3 halves. I can split x to the 3 halves. Guys, why is it doing this? This is so annoying. Oh, no worries, buddy. No worries. Okay. Yeah, no worries. And no worries. Um, So AMK, yeah, I've got a video on here and on my YouTube about questions here or topics that I think are likely to come up on paper 1. Okay, so go and give that a watch. Okay, so I can split 3 halves into half plus 1, and then when I do that, okay, I'm going to circle option number 2. You have x to the power of 1 times x to the half. Rules of indices state that when I multiply, I'm going to add the powers. It says 1 over x root x. Okay, does that make sense, guys? Hello, Amy. Welcome, welcome. Thank you for joining, Kate. Thank you for joining, Kate. AMK says, will I do a live tomorrow? Tomorrow, guys, I won't actually be live actually, okay? The next live will actually be Thursday, okay? But tomorrow, unfortunately, yeah, because I've got like an evening, yeah, like appointment that I need to actually attend. So tomorrow I'm not actually live in the evening, okay? But hopefully I'm back on Thursday. Okay. Question number 3. Okay. So when theta is small, find an approximation for cos 3 theta plus theta sine 2 theta, giving your answer in the form a plus b theta squared. For this question, guys, use your formula booklet, and again, we'll have a session dedicated to how to maximize and make use of your formula booklets. We know from our booklet that sine theta, okay, is approximately equal to theta for small values of theta, and that cos theta is approximately, okay, for small values of theta is approximately equal to 1 minus a half theta squared, okay. So all I'm going to do is just sub these into here, okay, replacing theta with like 3 theta. Okay, so cos 3 theta becomes 1 minus 3 theta, okay, all squared over 2. AMK, yeah, I'll try and do that. Yes, I'll try, okay. Guys, actually, let me know here, what exam boards are you guys here? And also, what date is your first exam actually, okay? I know some of you are doing your core pure AS tomorrow for further maths, okay, so good luck for that tomorrow if you're doing it. Okay, and then plus this theta sine 2 theta, okay. Well, again, I'm gonna have, oops, guys, why is my tablet doing this tonight? This is so annoying. Mine's a 15 minute. Okay, no worries, Kate. So the plan will be to try and do as many past paper lives as we can, okay, as we approach your exams. Sorry, just give me 1 second, guys, try and fix this. Okay, and then lastly, okay, we've got theta sine 2 theta. Okay, so sine 2 theta again, yeah. Okay, replace that with theta, so we're gonna have theta times sine 2 theta. So we're gonna have 2 theta squared there. Okay, when I plug it in, and then all I'll do now is just manipulate it and rearrange it. Okay, does that make sense, guys? What I'm saying so far, does it make sense what I'm saying so far? Let me know in the chat. Is it making sense what I'm saying so far? So from our formula booklets, we know that sine theta is approximately equal to theta for small values of theta, and that cos theta is approximately, okay, 1 minus theta squared over 2 for small values of theta, okay? And all I've done now is just plug in those numbers, replacing theta with 2 theta or 3 theta wherever I can. Okay, so let's just simplify this. I'm going to have 1 minus 9 theta squared over 2, okay, plus 2 theta squared, okay. When you simplify this fraction, you get 1 minus 5 theta squared all over 2, okay. I know I've missed like a step there. Hopefully your rules for fractions. Hello, Gia, welcome. Hope you're well, okay. So guys, let me know, yeah, does that make sense for the first 3 questions, okay? If you got those, guys, well done. If you didn't get those, I hope it makes sense now, okay? But drop any questions you have in the chat. Otherwise, we'll move on. Hello, Moneyball. Welcome. Okay, otherwise, we'll move on. Okay. M says maths GCSE is really easy for me. That's cool. Yeah. Okay, so let's go back to the page now. So let's go back to the question. That was yesterday's one. Okay, so 1, 2, and 3 are done. Question number 4. Okay, I'll give you 2 minutes, okay, to try this one. No worries. Okay, someone's put a flower. So yeah, you haven't got like a name actually, so I'll just put. Okay, thank you for the flower emoji. Welcome, guys. Guys, if you're new around there, make sure you give us a follow. Okay, and check me out on YouTube. Okay, press the subscribe button. Okay, and please, if you can, guys, yeah, help me try and get to 10K followers, ideally by the end of June. Okay, so share this account with anyone that is doing GCSE maths or A-level maths. Okay, so for this question, for part A, we are given that p of x equals 2x cubed plus 7x squared plus 2x minus 3. Okay, use the factor theorem to prove that x plus 3 is a factor of p of x. Guys, hopefully you're happy with this here. The factor theorem here states that p of x equals 0 if x minus a is a factor. Okay, so you plug in minus 3 into here and it will give you 0. Okay, therefore x equals minus 3 is a root, okay, to this cubic expression, okay, and thereby that proves that if x equals 3 is a root, therefore x plus 3 is a factor, okay? Does that make sense, guys? Does that make sense? Okay, Ed Irama, I think it is, yeah, do more of maths, yeah, I'll try and do as many as I can. How much do I charge you? If you send me a DM actually, I'll try and give you some prices. Hello, Samson K. Hello, Charlie. Welcome. Okay, so that's part A done, guys. All you do is just plug in minus 3 into here, and you'll get that P of x equals 0 when x equals minus 3. Okay, that's part A done. Okay, part B, which is slightly more trickier. Okay, again, I've got one way of working this out. Okay, so simplify this algebraic fraction. Okay, one way of doing it is recognizing that the denominator is the difference of two squares. Okay, and then one of your brackets will have to have a 2x plus 1 or a 2x minus 1. Okay, if it was me personally, I would do polynomial division, okay, for the top part of my fraction for x plus 3, get my quadratic, and then factorize that, and then cancel down where possible. Hello, L, welcome, welcome, okay? Does that make sense? Hello, Saeed, welcome, welcome. Hello, hello, hope you're well. Does that make sense, guys? Does that make sense? Let me know. Guys, if you're new around here, make sure you give us a follow. Okay, hello, Anna, welcome, welcome. Hope you're well. Okay, guys, just let you know, there'll be no live tomorrow night. I'm back on Thursday. Hello, Charlie, welcome, welcome. Guys, is it making sense so far? Is it making sense? Let me know, okay, let me know if it makes sense. Hello, Loretta, welcome, welcome. Okay. So type in ready, okay, and I'll do the answers. Hello, Ayub, welcome, welcome. Type in ready when you're ready. Okay, user says ready. Is anyone else ready? Thank you. Yeah, thank you, user, for liking. So user's ready. Anyone else ready, guys? Hello, hello, welcome, welcome. Hello, Anthony, welcome, welcome. Hello, Mohammed, Tahir, welcome, welcome. Hello, Andrew French. Guys, it's so quiet tonight again. What's going on? Can you hear me? Let me know. Can you hear me? Hello, Ace, welcome, welcome. Can we try and get 10 people in the chat tonight? Okay. So let's copy and paste this. Okay. Oops. Okay, so from part A, we deduced that x equals minus 3 is a root to the numerator of this fraction. So I'm going to do polynomial division. Okay, I'm going to do 2x cubed plus 7x squared plus 2x. Oh my God, this is so annoying. Why is it doing that? Hello, Anthony. Welcome, welcome. Hope you're well, my friend. Hope you're well. Okay, I'm doing some A-level lives in a minute, Anthony. Okay, so don't panic yet if it's not new to you, okay? This is A-level maths, yeah, so don't panic at this stage, okay? Minus 3, okay? And we're dividing that by x plus 3, okay? Because from part A, you know that that's going to be a factor, okay? No worries, no worries, okay? That's awesome, Anthony, okay? So dividing it, I'm going to have 2x squared here, okay? This times that, you're going to get 2x cubed plus 6x squared. It should be a squared there. Does anyone know why is my PowerPoint not doing this? Why are these like little like things coming out? It's so annoying. Okay, subtract it. Hello, Han Chinese. Welcome, welcome. Hello, hello. Hope you're well. As you're new around here, make sure you give us a follow, please. Okay, and check out the content on my page. Okay, on YouTube and on TikTok. Okay, x squared plus 2x. Okay, Anthony's got smile face. Thank you. Thanks so much for liking. Okay, guys, can we tap the screen, guys, and share the live out if we can? Plus x there. That times that is going to be x squared plus 3x. Oh, wow. So tonight we've got no audio issues, but we have got some PowerPoint issues tonight, but it is what it is. Okay, 2 minus 3x is going to be minus 1x or minus x. Okay, we put minus 3 there. Okay, oops, this is annoying now. Don't know why it's doing that. Okay, just extend this. Okay, the minus 1 goes to here. Okay, that times that makes it minus 1x minus 3. Oh my god, this is a joke. And Anthony's got some smiley faces. Anthony, welcome back, Anthony. Welcome back. It's nice to be on the call. Yeah, it's been a while. Subtracted, that goes to 0. That means my quadratic on the numerator is 2x squared plus x minus 1 and x plus 3. Again, I can now factorize that. So this part will factorize to 2x minus 1. Okay. And then x plus 1. Again, check that by your factorization. And then times that by x plus 3. Okay. And then divide all this, guys, by the difference of 2 squares here on the denominator. So on the bottom, I'm going to have 2x plus 1 times, oh my god. Why is this doing it tonight? This is so annoying. We've been doing so well today, and then now it's like playing up. Hello, Owen. Welcome, welcome, Owen. Hello, hello. Guys, if you're around here, make sure you give us a follow, okay, and press the subscribe button on my YouTube. Link is in my bio, okay. I've got lots of content for AS and A2 maths, so please check out the content on my page, okay. That's going to be 2x minus 1. 2x minus 1's cancel, so on the top, I'm left with x plus 1 times x plus 3 all over 2x plus 1, and that, guys, is going to be my final answer, okay. So rather than write it out again, we can just delete this, and that, guys, becomes the answer to my question. There we go, okay. That's 4B done, okay. So again, that was quite tricky and quite demanding. Okay, hopefully at this stage, I'm going to go. This is why like PowerPoint is like a joke. Like any issues to like go wrong, it will just do it for me. Okay, there we go, okay. Hello, Rays, welcome, welcome, okay. Let me know, guys, does that make sense? Okay, does that make sense? That was quite like a tricky question here, okay. It's quite, I think it was quite a nice question here, but there was a lot of like algebraic like moving parts to it. But hopefully it makes sense now. Okay, those of you that are actually wondering, yeah, the x plus 3 came from the fact that part A, it said that show that x plus 3 is a factor. Okay, hello, Mark Colicia, welcome, welcome, hello, hello. Hope you're well. Okay, now back to the question. That's 4B done. Okay, this one's slightly more trickier, but we'll give it a go. Okay, so I might use like a different method here to actually solve this. Okay, we'll give it a go. Okay, I just joined. What am I seeing? This is actually A-level maths, man. Yeah, don't panic here. This is actually A-level maths. Yeah, don't panic. Hello, Nick. Welcome back, Nick. Welcome back. Hope you're well. Hello, Faria. Welcome, welcome. Do not panic here, guys. If you just see, guys, here, don't panic here. This is like A-level maths here, so don't panic. Okay, guys, if you're new around here, make sure you give us a follow, okay, and check out the content on my YouTube, okay. Please obviously like this live, share it, okay, comment your topic requests, okay, but all lives get recorded, okay, and uploaded to the channel, okay, after each live, okay. I try and do it, yeah, lives like late at night, okay, but my job now is to try and help you grasp and gain as many marks as possible. Okay, I apologize for being a bit rusty on the last few days. Okay, but I'm picking particular topics, okay, and focusing my energy on that. Okay, because I want to try and help you maximize and capitalize on as many marks as possible. Okay, because A level maths is all about showing your full workings type of game. Okay, the more workings you show, the more marks you'll be given. Okay, although they are a bit harsher in terms of like marking, but when you show your full workings, okay, they will try their best to give you as many method marks as possible. Okay, and like I said, guys, yeah, okay, I have actually tutored, yeah, like A level maths, yeah, in the past few years. Okay, my history, yeah, if anyone's just wondering, yeah, I think, yeah, so um, in 3 years, so 3 years, yeah, yeah, actually, I got, yeah, so two students here got a grade B, one got an A. Okay, no one yet that I've actually tutored, yeah, has got like an A slash here, but okay, but I'm working towards, yeah, trying to get students in at their top grades. Okay, but my job is to try and help you pick as many marks and help you ideally get onto your first course or first choice university. Okay, come results day, yeah, in August. Okay, hello, Maisie, welcome, welcome. Hello, hello. Guys, anyone that's do see, guys, here, do not panic here. This is end of maths here only, okay? So do not panic, okay? But please do share this live with anyone that is doing A level maths, okay? Even AS maths, okay? Bits of it may be appropriate. Hello, Ghost, welcome, welcome, okay? I'll give you just another minute or so to try this question and then we'll show our answers, okay? But this is all to do with areas of sectors in radians, okay? So it's very, very, very similar to how we do it at GC actually, yeah. But there's one slight caveat with this, okay? Thank you, Nick, for liking. Okay, guys, tap the screen, guys. Yeah, if you hear it, guys, yeah, tap the screen and share the live out, okay? And put your topic requests here in this live, or even better, comment your topic requests on my TikTok or my YouTube videos. Okay, that way I'll see it more clearly. Okay, because the chat, unfortunately, yeah, doesn't actually save you after every live, so I may forget. Hello, Jack. Welcome, welcome. Okay, right, guys, type in ready in the chat when you're ready, and we can talk about this question. Hello, Naima. Welcome back. Hello, 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 hello. Welcome, welcome. Hope you're well. Okay, for anyone that's new, guys, okay, I'm doing lots of A-level preparation. Okay, I won't be live tomorrow, unfortunately, because I've got some evening commitments. Okay, but my next live should hopefully be on Thursday or Friday. Okay, um, okay. So type in ready when you're ready, guys, and we can talk about this question. Okay, let me just get a sip of water because I'm getting a bit like a dry mouth. Okay. So type in ready when you're ready, guys, and we can talk about this question. Hello, Paris. Welcome, welcome. Okay. I think we're taking the answer as yes. Okay. Oh no. Why is it crashing now? Hmm. Oh, this is annoying now. Why is it playing up now? Oh, sorry, guys. Just give me 1 second to try and sort this out. There we go. Okay. Oh my God. Why is. Hello, Jack. Welcome, welcome. Why is it playing up now? This is annoying. Why is it always like technical issues whenever I'm on? Okay, but let's just talk about it. Okay, so diagram shows a sector AOB of a circle with center O and radius R. The angle AOB is in theta radians. Okay, so do not panic here when it says like radians here. Okay, the sector has area 9 centimeters squared and perimeter of 15. So that R um, satisfies the equation 2r squared minus 15r plus 18 is 0. Okay, so step 1, use the formula for the area of the sector, okay, which is a half r squared theta, okay, so a half r squared theta, where r is your radius and theta is the angles in degrees, okay. We are given that the area is equal to 9, okay. We don't know what r is, okay, but we're going to form another equation that links the perimeter. So we know that the perimeter is equal to 15. So the arc length is r times theta, where again r is the radius here and theta is the angle, okay. So to work out the arc length, we do r times theta, okay. So that is your first step there. Okay, so the two equations that you should have actually here, because at the minute I can't actually write it, is a half r squared theta equals 9, because the area of a sector in radians, okay, is a half r squared theta, where r is the radius here and theta is the angle in radians, okay, and then to work out the arc length, so arc length is going to be r times theta, so that is going to be the arc length there. Okay, so we can call that x, let's say. So x equals r theta, okay, or we can call it, yeah, just arc length, okay. We can then substitute the equation for the arc length into the area equation, rearrange it, and we get the quadratic 2r squared minus 15r plus 18 as required, okay. So does that make sense? Oh, hello? Hello, can you hear me, guys? Hello, can you hear me, guys? Hello, hello? Let me know, guys, can you hear me? I think it is a bit nick, yeah. I think it's playing up a bit again, okay. Why is it doing this to me? Oh, God. There we go, okay. So let's just start again. Oh, sorry. Oh my God. This is so annoying. Right, here we go. I swear, like every live video, there is like a technical issue. Okay, so what was I saying? Sorry. So the area, okay, the area of the sector is a half r squared theta. Oh my God. Why does this do this? Like, it was working fine today. And then like it decides to like play up now. Guys, just give me 1 second. Oh my God. No, I can't actually tab actually out. Oh my God. Why is it playing up? This is so annoying. It was literally like it was working fine earlier today. Right, here we go. I think it's like fixed now. Okay, so let's oops. Sorry guys, okay. So the area is equal to a half r squared theta. I don't know why it's doing that little like doing like lines. And the arc length is equal to r times theta. Okay, which is equal to AB, so that's the arc length. Okay, that's the radius. Okay, the perimeter, okay, is 2r plus the arc length, okay, which I'll just call that as, so it's 2r, Okay, why is this playing up today? Oh my God, every lava I've got like a technical issue. So frustrating. Actually, the teaching's going fine today, but like the computer's not on my side. Okay, so 2r plus r times theta is equal to 15, and that a half r squared theta is equal to 9. And the question, okay, rearrange the second equation to make theta the subject and then plug it into here or vice versa. Okay, so if we just plug in here, let's make theta the subject of the first equation. So times up by 2 and then divide by r squared. We'll have theta is equal to 18 over r squared. Okay, plug that into there. Okay, you're gonna have 2. Wait, is that right? Yeah, I think that's right anyway. So 2r plus 18 over r. Okay, because the r over r squared, yeah, they're gonna cancel. Okay, is equal to 15. Okay, and then if you rearrange that, okay, times up by r, subtract 15, and you do indeed get 2r squared minus 15r plus 18, and that's how we get our answer. Okay, does that make sense, guys? Let me know. Does that make sense? Let me know, okay? And then the final part to say, okay, is to go from degrees to radians, you times by pi over 180, and then to go from radians to degrees, you times by 180 over pi. Okay, so you can do this method using the GCs like formulas. Okay, that would also work. Obviously, yeah, just be careful. Yeah, okay. So from degrees to radians, you times by pi over 180, and then from radians to degrees, you times by 180 over pi. Okay, so that's part A done. Okay, part B, find the value of theta. Okay, explain why it is only possible to have one value. Okay, so we're going to factorize this quadratic. Okay, so you can either just use the formula or factorize it. Okay, I'll try and see if I can factorize it. Oh, step wrong one. Okay, so what we have is here. So let's just go to slideshow. Okay, so we have 2r squared minus 15r. Hello, Alex. Welcome. Plus 18 is equal to 0. Okay, let's solve this quadratic. Okay, so let's try and factorize here if we can. So 2r subtract something, and then r subtract something. Okay, I'm going to do it here by like a trial and error method, but you can obviously use the formula or complete the square. Okay, or use the AC method for factorizing. Okay, so if I factorize this, okay, factors of 18 are going to be 1 and 18, 2 and 9, 3 and 6. So let's try 3 and 6 first. Okay, so let's put 6 here and 3 here. Okay, and if I'm not mistaken, you get 2r squared minus 12r minus 3r, which makes that, and then minus 3 times minus 6 makes positive 18. Okay, so our two solutions to this quadratic, okay, are going to be r equals 3 halves or r is equal to 6, okay? So that will be the solution to my quadratic, okay? Now the question says, why can we only have one possible value for r, okay? So this will come down to, okay, the question, okay? So explain why it only has one possible value, okay, for theta, okay? Oh, sorry, sorry, that's r, sorry, okay, okay. So once we worked out what r is, we can now plug it into the formula, okay? Length equals r times theta, or even better, the area equals a half r squared theta, okay? Oh, I messed it up there. That should be there. Should be there. Let's do this one a bit. Okay. I'm guessing it's because you can only have like a positive, actually a value for theta, okay? But we've got that the area equals a half r squared theta. The area equals 9, okay? And then we now know what r is, so we can rearrange it here. So we're going to have 2a over r squared is equal to theta, okay? A is equal to 9, okay, because that's the area, okay? So you're going to have 18 over r squared is equal to theta, okay? Remember, theta is in radians, okay? It's just an angle, okay? So if I plug in, okay, r is 6, I get that theta is equal to a half. If I plug in 3 over 2, okay, I square that, I get 9 over 4. I'm doing 18 divided by 9 over 4, so same as times by 4/9. Okay, I can simplify this again. Yeah, just do it on your calculator, guys. Yeah, in the exam. Okay, I'm being a bit not lazy, but I'm trying to get an answer. We've got 8 there, so theta equals 8. Okay, so why can we only have one value? Well, because one way of like summarizing the question, okay, if you go from um, radians to degrees, if you times that by 180 over pi, okay, if that number is not between 0 and 360, okay, that'll be out of your range. Okay, yep, spot on, yes, okay. So Nick says, yeah, it's more than actually 1 full turn, yes, it's more than 1 full turn. Okay, so theta has to be between 0 and 2 pi radians. Okay, 2 pi radians here means 2 times pi, so pi is equal to 3.14. If you do in your calculation here, so 2 pi, okay, is going to be roughly 6 point something or 7 point something. Okay, 8 is bigger than 2 pi, therefore that's out of my range. Or another way, if you're unsure, is to convert radians to degrees. Okay, that will show you that my answer is bigger than 360 degrees, and therefore that's not possible. Okay, remember it's a sector of a circle, so the angle is over 360. Okay, okay, and that's another way to do it. Okay, hello Turk. Okay, thank you so much. Yeah, thank you Nick for liking it. Thank you Nick. And thank you so much for the user for liking. Okay, that's my answer for that. Okay, thank you Nick here for clarifying. Okay, but basically, yeah, 8 is bigger than 1 full turn. Okay, and obviously a circle has to add up to 2 pi radians or 360 degrees. Okay, and remember, from radians to degrees, we times by 1 over 80 over pi, sorry, 180 over pi, and then vice versa, times pi over 180 to go from degrees to radians. Okay, that's my answer for that. Okay, well then, yeah, well then, if you got that, okay. Question 6 here. This was quite a nasty, I think it's quite a nasty question. Okay, but I actually quite like it. It's quite a tricky one, but I quite like it. Okay, So question number 6, it says Sam goes on a diet. He assumes that his mass, m kilograms, after T days decreases at a rate that is inversely proportional to the cube root of his mass. Part A, construct a differential equation involving mt and the positive constant k to model the solution. Okay, so we know that dm by dt is equal to some constant, so k times 1 over the cube root of m. Okay, so you can write that, yeah, in algebra. Oh my god. Okay, slide, copy and paste that with the slideshow. Okay, so step 1, we say that dm by dt, okay, because it's the rate of change of his mass with respect to time is equal to some constant k times by 1 over the cube root of m, which I can just write it as dm by dt is equal to k over the cube root of m, okay? And then I'm guessing in part B, we're going to be asked to solve the differential equation, okay, m in terms of t, okay? So that is my answer for that, okay? I think, yeah, that was quite like a nice 3 marker there, okay? This is similar to like, yeah, like, just see here, when you have that direct and inverse proportion, except here we're looking at a differential equation rather than 2 variables here, which is obviously back to back, okay? So this is going to involve here some like integration, okay? But that's part A done. Are there any questions, guys? Yeah, any questions in the chat? Hello, Stacey. Welcome, Stacey. Hello. Hope you're well. Hello, E Love Heart. Welcome, guys. Thank you so much here. Thank you for liking. Thank you so much here, user 1, 2, 3, 4, 5, 6 for liking. Thank you, Nick, for liking. Thank you again, Ashia. Thank you, user, for liking. Hello, Melissa. Welcome, Melissa. Hope you're well. Guys, if you're new around there, make sure you give us a follow. Okay, and check out the content on my YouTube. So E says yes. Thank you. I understand, Ashia. Awesome. Good job. Okay, good job. Okay, so obviously I read it carefully. Okay, for A-level maths here, the chances are you'll be forming it and solving a differential equation. Okay, involving like one variable. Okay, but that's part A done now. Okay, so the part B, I think is going to ask us to solve it. Okay, right, okay, only has actually. Okay, part B, explain why Sam's assumption may not be appropriate. Okay, the plain and simple reason is your weight can never obviously reach 0. Okay, so they'll come to a point where Sam's weight will just plateau. Okay, regardless of his calorie intake and his obviously exercise intake. Okay, so M can never ever reach 0. Okay, because it's not possible to have like a human weight of 0. Okay, so eventually his weight will just plateau. Okay, and he will no longer lose weight. Okay, because obviously otherwise, yeah, sorry, it sounded beginning, but otherwise, yeah, the person just obviously dies, okay? Because if you no longer eat, then that's what happens. Yeah, but sorry to sound obviously a bit grim there. Okay, hello, Zara, welcome. But yeah, obviously don't put that he dies, but I mean just say that obviously yeah, it's not actually possible, okay? But yeah, does that make sense, guys? Does that make sense? Are you happy with that? Hello, Runa, welcome. Okay, are there any questions, guys? Let me know. Hello, Zara, welcome. Hello, Runa, welcome to the chat. Okay, E says yes. Okay, awesome. Okay, question number 7. Okay, so working obviously a bit faster today. Okay, I know in the exam here, obviously it's the 2-hour exam actually, and I'm doing obviously a bit slow. Okay, thanks so much. Thank you, Zara, for the follow. Guys, if you're new around here, make sure you give us a follow, and more importantly, check out the content on my YouTube. Okay, and anyone here that is on YouTube tonight, please come over to the TikTok. Okay, as we're doing a live here. Okay, and help me reach my goal of 10K followers and 3K subscribers on YouTube. That is the plan, okay? Thank you for the follow. Thank you so much here. Thank you, Nick, for liking. Yeah, thank you, user 1, 2, 3, 4, 5, 6 for liking. Thank you, user. Thank you, user, for liking. Okay. Oh, thank you so much here. Thank you for the rose. Yeah, thank you so much, E, for the rose. Yeah, that's still kind of okay. Thank you for the rose. Yeah, I appreciate any gifts, okay? Any gifts. Yeah, okay. I really, really appreciate. Okay, thank you for any gifts tonight. Okay, question number 7. Find the values of k for which the equation 2k minus 3 times x squared subtract kx plus k minus 1 equals 0 has equal roots. That's when the discriminant is equal to 0. So you set b squared minus 4ac equals 0, okay, to have what we call, yeah, like a repeated root, okay, or equal roots. Okay, so a equals 2k minus 3, b equals minus k, c is k minus 1. So sub it into b squared, yeah, minus 4ac, okay, and then solve your quadratic involving k, and you will get your set of values of k. Okay, so let's obviously do it here. So let's do it together, okay, if we can. Okay. In fact, yeah, let me just try. Oh, if it comes up here, paint. Might be easier. Might be easy to just do it like the paint up, okay. See if this is any better, okay? Oops, okay. So we're going to use the part, so b squared minus 4ac is equal to 0, okay? Because that's the part where we have repeated roots, okay? Or another word for it, yeah, equal roots. Okay, so when the quadratic essentially has that one root, yeah, and it touches the graph, okay, on the x-axis at one point. So a equals 2k plus 3, b equals minus k, c is k plus 1. Okay, so be careful here with your subbing in. You're going to have minus k all squared here, so it'd be k squared there. Okay, minus 4 lots of 2k plus 3. Okay, times 2k minus 1. Okay, we're going to have a quadratic, okay, which we can then solve, okay, either by factorizing or completing the square or the quadratic formula. Okay, but again, I would obviously urge everyone, where possible, to show your full workings. Okay, I know someone, yeah, like will come at me saying, "Oh, well, I can just plug it into the calculator and get my roots." I mean, that also works, but obviously, examiners obviously want to see your obviously your full answer. Okay, you don't get any marks, unfortunately, for using the device to help you get the answer. Okay, you are obviously given marks for your written communication. Okay, so that's how exams work. Okay, unfortunately, or fortunately. Okay, k squared, k minus, sorry guys, if I'm talking a bit fast here tonight. Okay, so I'm going to have 2k squared minus 2k minus 3k, so that's going to be minus 5k, k plus 3. Thank you, yeah, thank you so much, yeah, thank you, user, for liking. Okay, expand the bracket, collect your like terms, okay, and then solve the quadratic, okay, using any method you want. Okay, subtract 12 equals 0, solve your quadratic, okay, and then you will get your two solutions, okay, for which this quadratic has equal roots. Okay, so let's actually finish it off now. Sorry, I'm being a bit slow now. So, okay, so let's just bring it over to the right-hand side. We're going to have 7k squared, okay, when you bring it over here to the right-hand side, plus 20k plus 12, okay. Anyone want to fancy factorizing this, or do you want to watch me do it? I don't mind. Or anyone got any answers for this? They're happy to share. Okay, we can factorize this quadratic here, if I'm not mistaken, okay, into 7k plus something, and then k plus something. Again, I would advise you, the formula is probably a bit quicker at this stage, okay, but I just do this here by trial and error, okay. So let's work out two numbers here, the times to make 12 and add to make 3, and when one of them times by 7k and the other by k adds to make 20. Okay, so what would that be? Well, if I do 3 and 4, what do I get? I'm gonna get 21. Nope, that'll be too big. What about 2 and 6? I think that might work. So 2 there, and then 6 there. That works, okay? Because then you get 7k squared plus 14k, okay, plus 6k plus 12, which gives you that. So your solutions are k is minus 6/7 or k is minus 2, okay? And they are your set of values of k for which the quadratic has equal roots, okay? That's my answer for that. Okay, anyone in the chat get that? Let me know. Okay. Also, let me know, yeah, if that makes sense now. Okay, well done. Yep. So Nick got that. Okay. Oh, is it? I've made a mistake. Let's just double check. So I brought this over here to this side. So I got 7k squared. Yeah, Nick, just double check your signs. Sorry, yeah, double check your signs. Or have I made a mistake? Ah, okay, no worries, no worries. No worries, yeah, no worries. So this part I brought over to the right hand side, okay, and I brought this to the right hand side, brought this to the right hand side. It all became positive, okay. Oh, no, sorry guys, it's my fault. Even tip that I'm a human being, okay, but that's my answer for that, okay. Does that make sense, guys? Let me know. Does that make sense? Hello, S Star. Welcome, welcome. Hope you're well. Hello, hello. Guys, let me know. Does it make sense now? Are there any questions? Okay. Remember, guys, the key with these lives are where possible and where appropriate to show your full workings. Okay. My job is to help you try and collect as many marks as possible. Okay. So don't panic if you don't get the final answer. My job is to try and get you at least 3/4 worth of the marks. Okay. But please, 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 okay, my big emphasis tonight, yeah, and in my other lives is where possible, please, please, please show your full workings because examiners, remember, guys, yeah, examiners are always looking to give marks, yeah. They're not looking to like knock off marks, yeah. They're always looking to give marks where possible, okay. That is one big tip, yeah, for A level maths, yeah, okay. I know obviously they're a bit more harsher on the mark scheme, okay, because they assume that you know more from GCSE maths, okay? But if in doubt, show your full workings in that 2-hour exam, okay, in June. Okay, Nick said the method is clear. Awesome, awesome. Hello, Ollie. Welcome, welcome. Yeah, thank you. Yeah, thank you for joining tonight. Okay, guys, if you're new around here, make sure you give us a follow, okay? And the link for YouTube is in my bio. So if you're able to subscribe to it, then please obviously subscribe and help me reach 3K. Okay, we're so close, I think, here to 2.8k now. Okay, question number 8. Yeah, I think this one's quite a nasty question. Yeah, okay. I mean, it's doable, but I think it's quite nasty. Okay, part A. Given that u equals 2 to the x, write down an expression for du by dx. Okay, so this is either one that you will know or you won't know. Okay, but where possible, I would advise. Hello, sir. Welcome, welcome, sir. Hello, Brick City. Welcome, welcome, sir. Oh, thanks so much. Yeah, thank you for the rose, sir. That's so kind of you. Thank you so much. Yeah, thank you for the rose, sir. That's so kind of you. Okay, I think we are a bit off my target actually tonight. Oh, sir, said like another gift. Thanks so much for the gift, sir. That's so kind of you, sir. You legend, okay? You absolute legend. Thanks so much for the, okay. And also for Ashley, you legend, yeah, you absolute legend, okay? Thank you so much, yeah. You are one of the OGs, sir. You're my favorite Key Stage 2 TikToker, okay? I think the best to count out the hands down, I think, okay? So anyone that has a child here that is doing SATs next year, or even year 7 maths or 11 plus, please check out Pretty Super Turkey because that guy is a legend. And every time he's live here, he never actually fails to obviously cheer me up. Okay. But the guy is a very, very like polite, yeah, and a very, very kind teacher. Okay, so please, yeah, check him out, guys. Give him a follow. Okay, show him some love on his page. Okay, and give him a follow, yeah. Okay, and check out his content. Okay, but anyone that's in year 7, year 8, or even year 9, okay, check out the content on his page. And also, his videos are also appropriate for GCSE Foundation Maths and also GCSE English as well, I'd say. Okay, Hello, Star. Welcome. Yeah, sorry. Back to question here, but no worries, no worries. Thank you for coming by. Yeah, thank you for coming by. You legend. You're my favorite. I think yeah, like TikToker out there. I think okay, or one of my favorite. I'd say at least. Okay. So looking in our formula book here, if you're not sure, okay, if we differentiate this, okay, this is a bit yeah, it's a bit more of like one that you might know or not know. Hello, but welcome. Hello, hi. Yeah, thank you so much. Yeah, thank you for joining. Okay, it is A-levels. Yeah, it is actually A-levels. Yeah. It is tricky, sir. It is tricky, okay? Hello, Rami. Welcome. Yeah, it's actually quite tricky, okay? But do not panic, okay? Do not panic, okay? So sorry, yeah. So let me sorry. Let me just check the formula sheet. So I'm speaking a bit fast now. Let me just look at the formula sheet, okay, and see if it's on the formula sheet, okay? But it's either one that you will know or you won't know, and that's fine if you don't know it. Um, that's the wrong one. Second. AQA formula sheet is on here. I can't actually see it. Okay, but basically the derivative, so du by dx is 2 to the x times natural log 2. Okay, so it's 2 to the x times natural log of 2. Okay, so that is the solution to this problem. Okay, so it's 2 to the x, okay, times natural log 2. Okay, let me just check in a shit. Give me just 1 minute here because I'm checking on my phone here. Give me just one more minute here to check the formula sheet on the EdXL one. Is it on the EdXL formula sheet? Let's just double check because they should actually technically do it or be similar. Is it on here or not yet for the derivatives? Um, okay, it's not on the EdXL one. Okay, if I'm not mistaken. Okay, but basically the derivative of 2 to the x is 2 to the x natural log x. Okay, so that's the answer for part A. Okay, again I'll write it out in a second, but I'm just double checking. Is it on here? No, derivative of tan cosec sec cot. Okay, it's not on here. Yes, not on here. I don't think. Okay, it is not on the EdXL one either. Okay. That's fine. Okay, yeah. So learn this, guys. Yeah, learn this. Yeah, yes, yes, Nick. Yeah. Okay. So take logs here if you're unsure. Yeah, and differentiate from there. Okay, but you will get du by dx equals 2 to the x natural log 2. Okay, and that will work for any number here. So that's 3 to the x. Okay, the only one that it will not work for is actually e to the x. Okay, because if you differentiate e to the x here, that becomes e to the x, but that's because that has like a special case here. Okay, I'd rather not give the reason why right now, but yeah, okay, because e is like a special number. Okay, anyway, that's part A done. Okay, what about part B, guys? Okay, find the exact value of this integral, fully justify your answer. Okay, and it's worth 6 marks. Okay, so that actually looks pretty nasty. Okay, so let's do part A first. Okay, so let's just copy it onto my paint tab. Okay, and then let us try part B. Okay, okay. So for part A, so the u by dx. Okay, again, if you're not sure, please obviously learn this from today. Okay, if you differentiate a constant here, so a to the x, it becomes a to the x natural log of a. Okay, in this case, a is equal to 2. Okay, so, okay, where ln2 is just a number. Okay, ln2 is just a number. Okay, now what about part B, guys? Okay, so we'll obviously use here, obviously part A to help us. So we're going to use a bit of like substitution here. So, yeah, to obviously work out our answer. Okay, if we let u equal 2 to the x, okay, then I can change this integral into the integral of u times the square root of 3 plus u, okay, du, okay, that should be a u, not a v, sorry. It should be a u there, I apologise. Okay, so we've got u equals 2 to the x. The u by the x is 2 to the x. Natural log 2. Okay, and what I'm going to do here is I'm going to make du the subject, okay, so or the x is subject, okay. So if I flip both sides, okay, I get dx by du equals 1 over 2x log 2, okay, and it is going to become clear why as I'm doing that in a second, okay, and then times up by du, so we're going to have dx is equal to 1 over 2 log 2 du, okay, and now I can change everything here like into like du's, okay, if I'm not mistaken, okay, so let's just rub this bit out, okay, and I'll rub this part out here, okay, just like redo it. Guys, is it making sense so far? Let me know, guys. Is it making sense so far? Okay. So this is, yeah, it is obviously done here by substitution. Okay. But it is like manipulating the expression. Okay. So it's to integrate something here a bit more simpler. Okay. So here I'm going to have, okay, 2 to the x. Okay. Awesome, Nick. Awesome, awesome. Okay. Root 3 plus 2x. Okay. Now I can replace the dx with 1 over that. So times by 1 over 2x log 2. Okay, because look at this part here on the right. Dx equals 1 over 2 to the x log 2 du. Okay, so du. Okay, I can cancel these together. Okay, that becomes a constant. So I'm just going to be integrating 1 over natural log 2 of the integral, okay, of root 3 plus u du. Okay, are we happy with that so far? Is it making sense so far? Okay, so this way, yeah, becomes a bit more trickier. Okay, obviously change our limits. Okay, so x is 0, x equals 1, x is 0, 2 to 0 is going to be 1. So we're going from the limit of u equals 1 to the limit of u equals 2. Okay, when you plug these numbers into this one here, okay, x is 0, x equals 1. Okay, and now we need to integrate. Hello, funny monkey. Welcome, welcome. Hope you're well. Okay, thanks so much here for joining tonight. Okay, guys, if you're new around there, make sure you give us a follow. Okay, so what happens now? Well, we need to integrate 3 plus u, don't we? Okay, so this is where it gets a bit more trickier. Okay, so what is the integral, okay, of 3 plus u to the power of a half? Okay, so we're going to think of this, okay, as reversing the chain rule, okay? So I want to pick a function that will differentiate to give me this, okay, one way to do it, okay, is to add 1 to the power, divide by the new power, okay, because what happens if I differentiate 2/3 brackets 3 plus u to the power of 3/2, okay? If I differentiate that, what do I get? So here I'm doing like the reversing the chain right here. So I'm doing like reverse integration. Okay, so I'm guessing, okay, what my answer is. Okay, if I differentiate this function here, what do I get? Yeah, okay, yeah, spot on, Nick. Okay, so when I differentiate this here with respect to u, it goes back to this part here. Okay, so integrating this goes to this. Okay, obviously not forgetting our 1/log2. Okay, so let's just delete this so we've got a bit more space here. Our paint is a nightmare, to rub out everything. Is there not way to rub out more quicker? There isn't. Hello, Anonymous. What's going on? Hello, hello. Hope you're well. We're just doing some A-level maths tonight. Okay. We're obviously meant to be having here for an hour, but yeah. But we'll finish up, I think, yeah, after this question, I think, okay, because I want to make it like a nice short live tonight, okay? Thanks so much, yeah. Thank you so much, Nick, for liking. Guys, can we get to 10k likes before the live finishes tonight, okay? By liking, by commenting, by sharing, it allows more people to come onto the FY page or the For You page, and thereby more and more A-level students will find me and follow me. Okay, so finally, sorry guys, yeah, it takes me ages to rubble this actually. Okay. Also, guys, I know many of you are obviously thinking, "Oh my God, yeah, it's just a 2-hour exam." Okay, do not panic about timing just yet. Okay, we are going to start working at a faster pace, okay, during the half term and obviously after half term. But at this stage, my main concern, yeah, is obviously answering each question, okay, on the main objective, okay. So do not panic here too much here about timings just yet, okay. So we're gonna have 2/3 here. So we're gonna have 2/3 natural log 2, okay, and then we're gonna have 2/3 brackets 3 plus u, okay, to the power of 3/2, okay, between the limits. Oh, what I've put that twice, sorry, ignore that, sorry. I've put 2/3 here, obviously twice, so ignore that. Okay, between 2 and 1, okay. Are we happy as to why the limits here are now 2 and 1, guys, okay? Are we happy as to why it's 2 and 1 for the limits? Hello, hello, Gillian, welcome, thanks so much. Thank you, Nick, for liking it, guys. If you're here, guys, yeah, please tap the screen, guys, okay, and share the live button if you can, okay. Although we are actually finishing quite soon, but there's no harm yet in that sharing live. Spot on, Nick. Yep. So Nick knows why it's 2 and 1. Okay, spot on. Okay, and then all we do now here is just plug in the values. So 3 plus 2 to the power of 3/2, times it by that, subtract 1 plus 3 to the power of 3/2. Okay, so you have 4 to the power of 3/2 times 2/3 log 2. Okay, do your subtraction and you'll get an answer. Okay, I'm being like a bit actually lazy because I haven't got my calculator. Okay, but anyone want to give me an answer for this? Okay, it says leave your answer here in exact form. Okay, so we've got the bigger limit. We've got 2/3 log 2 times by 5 to the 3/2. Okay, it is a times again, just to be clear. It's a times by, and then subtract 2 over 3 log 2 times 4 to the 3 halves. Okay, can anyone like simplify this for me? Because I'm being a bit lazy now because I haven't got the calculator right at the second. Okay, I know what 4 to the 3 halves is if I'm not mistaken. That's root 4 cubed. So that'll be 8. Okay, so you're subtracting 8 over. I think so. Yeah. Let me just double check here. That's your marks. Yeah. Sorry. Yeah. I think exact means that they want it because I did this like earlier today. Sorry again. Yeah. Like, check my answers. Yeah. On the mark scheme. Let's just double check. Okay. They've left that answer. Yeah. I think it's a third. Okay. So when they simplify that, okay, they get 2/3 times 1 over log 2 brackets 5 root 5 minus 8. So that's what you should get, okay, when you simplify that. Hello, miss, welcome, hello, Akua Bata, welcome, miss, hope you're well. Hello. Yeah, yes, you can, Nick, yeah, okay. So simplify that, okay, plug it into your calculator, and your final answer will be 2/3 times 1 over log 2 brackets 5 root 5 subtract 8. Okay? And that, guys, is your final answer. Okay? Does that make sense? Okay? I know this last part, I'm being like, a bit like lazy here, but yeah, it's just like a bit about rearranging. Okay? But hopefully that makes sense at this stage. Okay? I'll give you a few seconds here to obviously screenshot that. Sorry, obviously it is not all on there. Let's just zoom out a bit. Oh, it's too small. Okay, 10 seconds to screenshot. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, let's move on. Okay, back to the question now. Okay, we'll do one more question and then we'll call it a night because I want to try and be fair. And also because, yeah, I don't want to make it like too long live stream, yeah, okay? So anyone that wants to watch it on YouTube after can, at their own leisure. Okay, so question 9a, looking at some quotient rules, okay, or the quotient rule. Question number 9, a curve has the equation y equals 2x plus 3 all over 4x squared plus 7. 9ai, find dy by dx. So you let u equal 2x plus 3, v equal 4x squared plus 7, the u by dx is 2, dv by dx is 8x, and then dy by dx is v du dx, subtract u dv dx. Okay, so v du dx, subtract u dv dx. Okay? And I think here, let's just double check out. I think that is also on your formula booklet. Okay, let's just check the an Excel one first. Okay, although yeah, they're all the same. Um, but yes, yeah, it is on there. Yeah, it is on there. Okay. So question one, yeah, why? Because u over v divided by dx. Sorry, yeah, is v dx minus u dv dx all over v squared. Sorry, and then you obviously simplify your fraction where possible. Okay. So divided by dx is v du dx subtract u dv dx all over v squared. Okay, and that, guys, will be your answer. Okay, so anonymous 127, yeah, star 30 says that's a yes. This is actually the full A level. Okay, bits of it I think is a yes. Okay, but this is like a full A level maths paper. Yeah, so this is ideally for the end of year 13. Okay, or anyone that is learning the A level maths course that is sitting as a private candidate. It's too easy. Okay, that's fine. That's fine. That's fine. Okay, but yes, this is aimed at. Okay, The questions do get harder. Okay, and then 9 hence show that y is increasing for the values of this. Okay, so that's when you set, I think, so that's when you set the derivative um, to be less than 0, I think. Okay, or the second derivative, yeah, less than 0. Okay, and then you solve that inequality. Okay, yeah, for part B. Okay, so we'll do question 9 here, and then I'll call it a night. Okay, because I'm trying to be a bit fairer here. Okay. If you're new guys here, I'm trying to go live here at 7:30 every evening. I won't be live tomorrow, guys, here because I've got some other commitments. So I'm back on Thursday, okay, and I'm going to try and do as many lives as possible, okay, doing random exam style questions, okay. So if you're new around here, give us a follow, okay, and hopefully my lives will start to be on YouTube soon, okay, once I sort out my issue, okay. But hello, Jason Tutor, welcome, sir. Hello, hope you're well. Hello. Hope you're all okay. Hello, S. Love Heart. Okay, welcome, guys. If you're new around here, make sure you give us a follow, okay, and check out the content on my page on here and on YouTube. Okay, I've only started in a maths year recently. Can I do stats and mechanics? I'm a bit more rustier in that. Okay, I'm gonna try and do some if I can, but my focus at the minute is just A level pure. Okay, I apologize. Thank you so much. Yeah, thank you for the follow and thank you for subscribing. Okay, as you're new around there, make sure you drop us a follow. Okay, and press the subscribe button. Okay, my YouTube link here is link in bio. Okay, and check out the content on my page. Okay, but unfortunately, I'm just sticking with pure maths in a minute. Okay, so I'm focusing on the pure maths. Okay, but I will try. Okay, my best to maybe do one or two, okay? But please don't hold me like accountable, okay? Because I'm a bit more riskier. But if you are desperate for help on stats and mechanics, then I would advise to check out TL Maths, okay, or Mr. Bison or Mr. Asprey, I think it is Mr. Ashbury, sorry. Okay. If that's the case, can you do proof questions? I can try, yes, sure, yes. Guys, if you're new around here, make sure you give us a follow, okay? And please share this with anyone that's in year 13 that is sitting there, pure maths exam after half term. Okay, I'm going to try and do as many pure math classes as possible. Okay, at the same time. Okay, I'll try and increase my hours here during the half term. Okay, but I may miss a day or two. Okay, because I want to have like a little break here if I can over half term. But I am actually tutoring as well. Okay. Um, Also, guys, let me know. Sorry, yeah. Last question. Sorry, yeah. Can you let me know, yeah, what are the dates? Sorry. So when is Pure 1, when is Pure 2, and then when is Mechanics and Stats? Okay. Someone tell me the date. Hello, and welcome, and hello, Little Wolves. Welcome, guys. If you're new around here, make sure you give us a follow. Okay. Okay, Anonymous says Pure 1 is on the 4th. So that'll be the Tuesday. So we've got what, 2 weeks today, I think it is. I mean, it's 2 weeks yesterday until just see maths. Question, well, yeah, you're right, Little Wolves, yeah, that is correct, yes. Pure 2 is somewhere on the 11th. Okay, cool. And then when is Mechanics and Stats? Or is that part of Pure 2? Ah, okay, so a bit more time. Okay. My focus here, I think, will just be pure maths, I think, unfortunately, but I will try my best to put out some videos for stats and mechanics, but I am a bit more rusty in that, to be honest with you. Okay, hello, as a race Russian, welcome. Said that right, okay? Well, okay. But thank you for letting me know this. So we got 4th, 11th, and 20th. Okay, or 4th, 15th, yeah, and 20th. Okay, cool. Okay, so we got 2 weeks here until the first pure one, and then roughly 3.5 weeks until the second one, okay, and then 4 weeks until stats and mechanics. Okay. Also, guys, yeah, last question. Sorry. Let me know what example are you, okay? Also, example wise here, do not panic. Okay? The, these questions will be relevant here, for obviously for all boards. Okay. The only difference I would say is different examples will offer like different marks. Yes. Okay, actually, I did B. Okay, sorry, yeah. So for part A, okay, and B, let's give it a go. So last question of the day, guys, and then we'll call it a night. Okay, I promise. Okay, so part A, use the quotient rule. So we let that is very thick there. So U equals, let's just do it like a different color pen. So U equals 2x plus 3. Okay, V equals 4x minus 7. Okay, the U by the X is going to be 2, and then the V by the X is going to be 8x. And then using our formula booklet, okay, or formula booklet if you're unsure, okay, the quotient rule states that the du over dx for U over V is V du dx subtract U dV dx all over V squared, okay, and that's how we differentiate a function that has a fraction, or an algebraic fraction, I should say, okay. So V du dx, so that times that, that's going to be 8x squared plus 14, subtract 16x squared minus 24x, okay, because you're subtracting this times this, okay, so be careful with the negatives, okay, all over V squared, simplify the numerator, and that's part A done, okay. Hello, O2, welcome, hello, hope you're well, butterfly, okay, so let's just simplify that bit. We're going to have minus 8x squared minus 24x, okay, so minus 8x squared minus 24x plus 14 all over 4x squared plus 7 all squared. And therefore, guys, that is going to be our answer for 2 marks, okay? I think it's a bit harsh here for 2 marks, but there we go, okay? But yes, the quotient rule is given to you on all of your example formula booklets. Okay, I've just checked it, okay? That's part A done. 9AII. Hence, show that the value should show that y is increasing when we have this. So that's when you set. So when you set dy by dx, okay, the inequality to be less than 0, okay. So you have this, okay, less than 0. So you're going to have minus 8 x squared. Hello, Angel, welcome. Minus 24x, okay, minus plus 14. Actually, yeah, sorry. Okay. Actually, sorry, yeah, actually, so it is when, dy by dx, okay, is bigger than 0, okay, because it's saying when it's increasing, yeah. So it's saying when the derivative, yeah, sorry, thank you, Nick. Okay, yeah, if it's increasing, yeah, that means when the gradient, yeah, is bigger than 0, okay. So you set this part equal bigger than 0, okay, because if you turn the fraction by 0, then that's going to change, okay. I'm going to multiply everything here by minus 1, So that will change the sign. I'm going to have 8x squared plus 24x subtract 14, okay, is going to be less than 0, okay, because when you multiply or divide by a negative number, the symbol of the inequality here switches, okay, it reverses, it flips, and then divide everything by 2, we get 4x squared plus 12x plus 14 is less than 0. Sorry, minus 7 is less than 0 as required. And therefore, guys, that is going to be our answer, okay? So when it says, these keywords here show that when y is increasing, okay? So these keywords here means that when the derivative is bigger than 0, okay? That's the key part to remember, okay? So that's when the derivative, so when f dash of x is bigger than 0. Make sense? Oh, guys, we're so close here to 10K likes, guys, yeah. Part B, find the values of x when y is increasing. So you solve that quadratic inequality. So let's just solve it together. Okay. Again, if you're unsure, you obviously find the roots. Okay, and you find when the quadratic, okay, is less than 0. So when the quadratic here, okay, is less than 0. But no, what was it? Sorry, what was it? Was it plus 12x minus 7 is less than 0? I think we factorize it if we can. Okay, we'll try 4x and x, although that's unlikely. Okay, and then we'll try 2x and 2x. So we want two numbers that times is to make minus 7, and when one of them is times by 4x, and x adds to make 12, when the factors of 7 are going to be 1 and 7, okay, I think I've got an answer. Let's just double check. So it'd be 2x minus 1 and 2x plus 7. We can just double check that by expanding it. We have 4x squared plus 14x minus 2x makes positive 12x, and then minus 1 times positive 7 is less than 0. So therefore, guys, that's going to be our factorized version. Okay, therefore our solutions, okay, will be minus 7 halves, or a half, okay. When is this quadratic below the x-axis? So you got minus 7 halves here, and you got positive a half here. So it's below the x-axis in this region here. Therefore, guys, our final answer of today's live is going to be x is between a half and negative 7 halves. So x is greater than negative 7 halves or less than 1 half. And therefore, guys, that is going to be our compound inequality, okay, our double inequality solved for 9b. And therefore, guys, that is going to be our final answer. Okay, does that make sense, guys? Does that make sense? Okay, that was definitely quite a tricky question. Okay, so we factorized the quadratic, okay, made it less than 0, found our solutions, and then remember, when the inequality is less than 0, That means where is the quadratic below the x-axis or x-axis is below it between -7/2 and +1/2. And therefore, guys, that is going to be our final answer to today's live, and we will call it a night. Okay, so that's question 1 to 9 done. Okay, on the AQA specimen. Okay, A-level maths pure 1 exam. Okay, are there any questions, guys? Any parting thoughts? Okay, I hope you found it useful today. Okay, sorry about any technical issues. Okay, hopefully the sound was clear. Okay, but I hope today's session, awesome, Nick. Yeah, no worries, no worries. Yeah, well, with me, Nick, here, it's just like a bit of practice here. Okay, I've done something like factorizing quadratics here that like I don't. Not to like sound cocky or arrogant, but I don't. I can get away with, yeah. I can get away with not using the AC method, okay, because I do it obviously by trial and error, okay. But if you're unsure, yeah, just obviously bring it into your calculator yeah, for A-level maths, okay. Remember, okay, always show your full workings because examiners are looking to give marks, okay, and not take any away, okay. That is true here for all levels of maths, whether it's primary school, secondary school, okay, university exams. Okay, you always show your full workings in your maths and science exams. Okay, for any mathematical calculations. Okay, because examiners want to try their best here to give as many method marks as possible. Okay, so remember my key motto, guys. Okay, my job is to try and make you collect as many marks as possible. Okay, and help us beat the examiner and get you your desired grade for A-level maths. Okay, and help you get onto your desired university course. Okay, but that's enough of me yapping today. Okay, I hope it's been useful. Okay, are there any last minute questions before I go? Okay, but we've done question 1 to 9 tonight. 1 to 9 tonight. Okay, and then we may look at at the second part on Thursday. Okay, tomorrow, yeah, there'll be obviously no live, unfortunately. Okay, okay, but yeah, okay. If anyone wants to find like more A-level actually maths videos, please check out TL Maths on YouTube. Check out Mr. Bison. Check out Mr. Ashbury, I think it is, or Asprey. Okay. And obviously check out myself here as well. Okay. But yeah, just type in A-level Maths here. Okay, and there's loads of content out there for pure maths. Okay, but I think TL Maths here and I think Bison Maths are one of the best in my eyes. Okay. But thank you for being here tonight, guys. Okay, make sure you obviously follow me, guys. Okay, before I go. Okay, and press that subscribe button on YouTube. Okay, but there's no questions. Then we'll finish for tonight, and I shall see you all hopefully on Thursday. Okay, can we hit 10k? Get 10k, guys, before I go. Okay, I'll give us a few seconds here to hit 10k, and I'll end the live. Okay, thank you so much, user 1233456. Thank you for liking. Thank you so much, Nick, for liking. Thank you, sir, for liking. British Institute, you are a legend. Thank you for all the gifts tonight. I appreciate it so much. Okay, thank you for all the gifts. It goes like a long way. Okay, but anyone that is doing the A-level maths exam, please share this account. Okay, and tell them about my upcoming live streams for A-level maths. Okay, for your pure 1 and your pure 2 exam. Okay, and check out my predictions on TikTok and on YouTube. Okay, I've put a list, I think, of like 8 to 10 topics. Okay, again, it's just a prediction. Okay, but practice your calculus. I think is the most important. Okay, and show your full workings. Okay, but when we hit 10k, then I'll go. Okay, but thank you so much for being here tonight, guys. Thank you for being here. Yeah, thank you so much. Okay. Okay, bye for now. Take care. All the best. Okay, speak soon. But bye for now.